I want to talk just a little bit about the progress check. I've got quite a few questions from people today, and it's really, really important. I can't do a lot of specifics here. I don't think I'm supposed to work out progress checks all the way online, so I'm going to have to give you kind of some general comments and kind of move from there. But I've got a lot of questions from people. This progress check is a rates progress check, and I cannot imagine that they will have an AP exam that doesn't ask you at least a couple parts of a problem having to do with rates. After all, calculus is a study of change, and a derivative is a rate. Okay, that's what this whole course is about. So a couple of things here. First of all, we saw this back, I think it was AP Prep number 2 when we were working with rate problems. The most important word on the AP exam is the word rate. Okay, anytime they tell you you have a rate, they are giving you a derivative, okay? And they're not gonna label it as a derivative, all right? So in this question, they're giving you, I think it's an f of t, and that's a rate at which water is coming into a tub, okay? That's a derivative, okay? They're also giving you a rate at which water is leaking out. And watch it carefully, because I think the water leaks out later in time. So I don't think in the early part of the problem it comes into play, but later, as you get far enough in, that's an issue as well. So you've got water coming in, you've got water going out, okay? Those are rates. They are giving you derivatives. Okay, and if you're not thinking about those as derivatives, you're going to miss every single part of all of this problem. And I guarantee you, you're going to have rates questions on the AP exam. Okay, that's one of the things that's most likely to show up on this. Something having to do with rate problems. All right, so again, if you're having trouble with this, one of the strategies that I really pushed back when we did AP Prep number 2 is the idea, pull yourself away from the problem, okay? Think about the idea in general. Look at your units, okay? They say something about water's coming in at a certain number of cubic inches per second or something like that, and it's leaving at a certain number of cubic inches per second, something like that. Okay, so make up some fake numbers, okay? Say you've got something like 100 cubic centimeters per second, and that's how fast the water's coming in, or maybe it's per minute or per hour, I don't really care. But anyway, let's say that it's leaving at 30 cubic inches per second, okay? If you want the overall rate of change of the water in this tub, okay, well, if 100 cubic centimeters come in and 30 cubic centimeters leave, what's the overall change? The overall change, you've got 70 total cubic centimeters of water that you didn't have before that second came by. Okay, what am I doing here? I'm subtracting those. I'm taking the rate in and I'm subtracting the rate out. Okay, so here's the point. That's the overall rate of change of water in the tank. Okay, a rate is a derivative. The rate of change of water in the tank. The rate of change of water in the tank is W prime. Okay, the derivative of your W function is f of t minus L of t. Okay, and I'm not sure where exactly that's going to come into play in this problem, but the point is that's the overall rate. So for example, if you wanted the total amount of water in the tub at a certain point in time, you would take the integral of this rate over that time period, and that would tell you, add up the change that's taken place. But that is a hugely crucial idea. And again, if you don't know what I'm talking about, you need to go back and watch all the videos for, again, I think it was AP Prep number 2. It was the rates FRQs. But this got hammered in those videos. And I think this is one of the 3 or 4 most important ideas on the AP exam. You're going to see it, okay? So anyway, problem 1, I think they're asking you to do a linear approximation there. Anyway, be careful because they give you a rate. And at that point, you only have water coming in. You don't have water leaving. Okay, so you don't have to worry about the water leaving. But the point here is that rate in that they give you in part 1 is a derivative. Okay, because it's a derivative, that's what you're going to use to find the slope of your linear approximation line. Okay, so those are some things that you need to keep in mind. Now, there's one other issue. Part 4 of this question is a related rates problem. Okay, they give you dimensions of this tub. Once again, I'm assuming that everybody has done the first half of the Saturday AP review, and hopefully more than that, because the sooner you get it done, the better you're going to be at all of this. One of the topics that got reviewed in the Saturday AP review was related rates. If you haven't seen those related rates reviews, if you haven't gone back to the book and you haven't done related rates problems, if you haven't watched those videos, definitely go back and watch the related rates videos from the Saturday AP review folder at the top of the file, at the top of our page. And you may want to go back through your book and look at some of those examples as well. But anyway, long story short, if you read it real carefully there, they're talking about a volume that's changing, okay? Because they're talking about a length and a width and a height, okay? So remember, when you're working with the related rates problem, if you're wondering how do you know it's related rates, well, notice they're talking about like a change in a height and dimensions of the shape. They're talking about all kinds of things that don't get referenced earlier in the problem. Okay, so remember the whole idea with related rates is you're having some kind of equation. Maybe it's the Pythagorean theorem, maybe it's a volume formula, an area formula. You've got a circle that's, the radius is changing, the area is changing, whatever it is, okay? And you take the derivative with respect usually to time, okay? Now I looked at this originally and I said, oh my gosh, I've got to do a triple product rule here with implicit differentiation. That's gonna be insane, okay? One of the things I really pushed, I've said before, when I was in AP Calculus, I had more trouble with related rates than almost anything else. As a calculus teacher, one of the questions that I have the least trouble with when I look at them is related rates problems. And there's one big difference in how I approach the problems. And here's the key. It's all about rates. You have to identify what are the rates that need to be involved in the problem. What are the rates that don't get referenced in the problem? What are things that are changing? What are things that are not changing? Okay? If you read the problem real carefully, you've got this water changing in a tub. Okay? They're asking you for the rate of change of the height. Okay? So they are asking you for dH dt. Okay? Now, if you think about it, water is building up in this tub, or dropping in this tub. The volume is changing. Okay? So you've got to get a rate of change of the volume, which, by the way, you should be able to tie back in with some of the earlier parts of this problem. Okay? If you notice, not everything in this problem changes. The length and the width of this tub are going to be stationary, okay? So I think they say maybe one dimension is 0.5 and the other is 4 or something like that. Anyway, remember that if you have constants, okay, they're not talking about a dl dt or a dw dt in this equation. So when I take the derivative, I don't want to have an L or a W in there. I need to find out how to get rid of them. And either I need to replace it with another variable, if I'm told the two things are equal, or if it's a constant and it doesn't change, I can lock in my 0.5 and my 4 there before I take my derivative. Okay, at that point, take your derivative with respect to t, and again, you'll only have a v variable and an h variable in there when you take your derivative at that point, and you should be able to come up with a solution. But really important stuff. I think this free response question is one of the most important free responses on the entire AP exam prep process, just because these are all things that are on the AP exam every year, okay? Really hitting some important things here. So hopefully that helps if you're having a little bit of trouble getting started on this.